taps will not reach the very bottom of the tap hole. Could you show us what that means, please?
The blind hole.
Blind hole, yes.
Yes. So blind hole. I'll sketch out here. A blind hole is a hole that does not go all the way through. So if we have it's weird. If we have a block of material here, in fact, I'll draw this a little bit differently. We have a block of material, and we put a hole in it. Like that. That's called a through hole. And then something like this, where the hole only goes part of the way through, that's called a blind hole. So a blind hole is just a hole that does not go all the way through the part, where white is the hole. Does that make sense?
It reminds me of CAD, when you can select the extrusion or the cut, and it's through all or blind.
Yeah.
And this is blind, you just tell CAD the length of the blind hole, right?
Right.
Okay, so the line here says taps will not reach the very bottom of a blind hole.
Yeah.
So that means the threads will not go all the way down. It'll stop like around here.
Well, for a through hole, you'll get threads all the way through. But for a blind hole, so I've got a tap right here. And you can kind of see that at the beginning of this tap, we don't have any threads right there, right? So if this tap is going down and making a hole, obviously this tap diameter is way too big, but let's see, maybe if I just, something like that. Anyway, if this tap is going down, right, there's going to be some distance down at the beginning of the tap, which is at the bottom of the hole, where because there are no threads on the tap, you're not going to have any threads down in the hole either.
Can I use the pen? Can you put color red?
Done.
Okay. So basically, threads will be here up to there, basically.
Something like that, yeah. Yeah, and a good rule of thumb to follow is there will be 3 to 5 thread lengths that do not exist at the bottom of your tapped hole.
Got it. All right, so let's just dive in right to the discussion questions.
Okay. All right. How might a designer hold your part or your material in order to facilitate the threading process? So, like, you're going to tap a threaded hole in a part. How do you actually hold that part? Can you hold it in your hand and tap it?
Well, you better be like Superman and have some really strong hands. But from the videos that we've seen on YouTube, we're going to use this thing down here that clamps it together. This thing right there.
Yeah, a vice clamp, table clamp.
That's what I would use to hold it in place while I do a tap.
Yeah, yep. Yeah, and you need to hold it in place with something that's really sturdy. So, some of the parts maybe you could hold it in your hand, but it's not good practice, and other parts you just wouldn't be able to hold in your hand. There's too much torque. It would twist in your hand. Okay, why is it important to know that holes cannot be tapped all the way to the bottom? And I should rephrase that. Blind holes cannot be tapped all the way to the bottom.
Because the tap itself doesn't have threads.
But why is that important to know as a designer? Why does that matter?
I guess when you're designing your CAD file, right? Because when you design a CAD file, you can put threads on it when you make the hole.
Okay. Right. So you can design threads or no threads, but I mean, practically speaking, why does it matter?
Yeah, good. Even a step further back. Why would it matter that the very last part? If I recall correctly, the video said something about there's some residue that's left. Can we change the color?
Mm-hmm.
How do you do that?
Just tap on, yeah, like that, it's fine. Oh, it's going to be black though.
So here, when you're doing the tap, you're drilling basically. Is that the right term? Drilling it? Tapping it. And here's just gonna be like a little bit of residue left. And when you put the screw in, you need a little bit of residue at the bottom because it's gonna take residue from the sides to create those threads. I suppose that's why you need a little space there, but it has nothing to do with thread. I don't know, actually.
It's a good guess. Let's say that we've got this. We've got this block of material here. And we create a blind hole. In it like that. And we have threads that go down to right there. And then we have maybe a plate right here. And there's a hole that goes through that plate. And then let's say that we have a screw. And we're going to screw this in. And we want to make sure that this gray plate is screwed in tightly against this black plate. We don't want the gray plate to be able to wiggle up and down at all. If our hole is only tapped down to the red, but we need to screw this screw all the way down to the bottom of the hole in order to tighten the gray plate against the black plate, like, are we actually going to be able to do that here?
I'm not associating how not being able to tap threads all the way to the bottom has to do with this, because if with the problem that you presented, I would just make the hole longer when I design the part.
Okay, but even if the hole is longer, let's say that the hole, you know, goes all the way down to
maybe yellow
to the bottom. I don't know why this isn't working.
Pink is good. Okay.
Let's say that the hole goes all the way down to the bottom here. Even if the hole goes all the way through, if it's only tapped down to here, your screw is not going to go any further than the tap length, the tapped thread length.
Well, you should have tapped all the way to the bottom then, so you can screw it in.
You should have, right? But that's the point. Like, we just said that this is we changed it and said that's a through hole. But if this is a blind hole. If it's a blind hole, you can't tap all the way through. There's a limit to how far your threads will go relative to the bottom of the hole. So if your threads can only go down to a certain point in that hole depth, and your screw can never go beyond that threaded depth, then your screw isn't going to be able to go far enough in. Does that make sense?
I don't know what it has to do with it. Like, why would somebody not want to thread all the way to the bottom?
You can't. There's a limitation with a tap. Like, if you're using a tap to thread a hole, which is the way that you thread a hole, there is a physical limitation on the tap itself that does not allow you or anyone else, even the Queen of England, to thread all the way to the very bottom of a hole. You simply can't do it.
Why don't they put... So here... Let's find the camera where it is. There, found it. So the thread stops like right there. This has no threads, is that what you're saying?
Right.
Why don't they put threads here?
It's a limitation in the, well, I don't know if you'd say it's a limitation in the manufacturing process, but there are taps that go a little bit further down, but there are no taps anywhere that go all the way to the bottom. And I don't know exactly why it is.
I think I may know. Because when you're making a tap, I think the first step is to put pressure on it, and then to start making the tap. And if we would have had threads here, it'll be harder to make that initial, almost like incision, like getting the part.
Yeah, I don't know exactly what the reasons are. Maybe that's it or one of them. But the fact is, you cannot buy a tap that will create threads all the way to the bottom of the hole. And if that's the case, you need to be very careful about the threaded depth and the length of your screw to make sure that your screw only needs to go up to the tapped depth and not past it in order to function correctly in the design. And this has happened to us on more than one occasion. This is an easy mistake to make.
It'll be nice if we could go over like a real example, because now I have like a basic understanding of just to kind of watch out for this. But if you were to ask me to create a tap to make sure that it doesn't go past like the problem that you presented, I'm pretty sure I would mess that up.
Well, the way to do it here is to use a shorter screw. Like this screw would not bottom out over here. That this gray plate would not be tight against the black plate. But if you used a shorter screw, one that ended right here, above the point at which the threads end,
got it.
Then it would bottom out all the way.
Okay, so what's the next question?
How would a designer know how deep to tap a hole?
I think that one has to take into consideration the calculations of how fragile the part will become depending on how deep the hole is. It also has to do with how close to the edge the hole will be. But imagine if this hole were to be all the way to down here, that makes the part more fragile than if the hole ends here.
Yeah, I mean, there's not like one right answer for that question. As the designer, you just need to be aware of what your parameters are and design something that's that's a terrible answer. Design something that's going to work. That doesn't really tell you anything. Well, I mean, this is a good example. You know, for example, you have to make sure that your screw will be able to go far enough down in the hole to fulfill its role in the assembly. So I guess the short answer is just it's up to the designer to understand all the requirements and make sure that mechanically your hole is tapped deep enough to accommodate the design.
And last question.
Why might it be more common for taps to be used versus dies?
So dies, we went over this. We went over the lesson, but dies is making threads on the outside, and taps, you're making threads so you can put like a screw in. And I think that it's more common for taps because a screw is a fastener, and fasteners are very abundant and very good quality. So why would you want to make a fastener at home, basically? There are already some really good ones on McMaster. So, and what's one reason? The other reason, number two, I'm hypothesizing, guys. I don't know if this is the right answer. But reason number two would be, let me think. Well, that's the only reason I can think of right now. Yeah.
I agree 100% with that. Yep. No reason to make a screw when they're so abundant and so cheap, but you can't really buy a threaded hole.
Okay, it came to me. I was watching a YouTube video, and this guy had some piece of equipment that he was doing, and the screws that he had came undone because it was like a screw on plastic, and he needed to make a tap so that he could use, what do you call those again? The hardware that you put in that's made of metal?
Helical insert?
Yes, he needed to put up a helical insert, so he needed to make a tap. And I think that is common, I suppose, like for threads to get worn out. So that's why taps could be more common than dies.
Yeah, I think the big reason was your first one, that
Okay.
screws are so abundant and so cheap, but you can't buy a threaded hole.
Yeah.
All right.
That's it.
If you found this content helpful, consider enrolling in our signature program at mypipelineacademy.com. Whether you're an individual interested in beginning a new career as a mechanical designer or a company interested in training your new engineering hires, our signature program helps students develop the practical skills they need to be productive mechanical design engineers. Seating is limited. We hope to see you there soon.